All right, the next couple of days you're going to be learning how to factor polynomials. This will help us be able to graph. So far we know how to graph from factored form, but what if it's in standard form to begin with? We have to be able to manipulate that and be able to write it in factored form. So we're going to take what we know about factoring quadratics, okay, and apply all those same skill sets to this. We're going to learn a couple new things as well, and by the end of this week, you guys should be able to change standard form into factored form for any polynomial that can be factored. All right, so let's take a look at what we'll be doing. So throughout this lesson, we're going to look at these three problems here. Okay, this first top one here, we have a fourth degree trinomial, and we're going to use our skills about factoring quadratic trinomials to help us with that. And here we have a cubic with four terms. All right, and so we're going to look at something called factor by grouping, where we could break this up. There's an even amount of terms. We could break them into two groups and see what we can do with our knowledge about factoring from there. And then this last one is a binomial. Right now it's a fourth degree binomial, but they have a GCF, and we take out the GCF, it comes a cubic. Okay, if we have a cubic binomial where the first term and the last term are both perfect cubes, okay, we can use a special pattern to help us factor the sum and difference of two cubes. So these are the three that we're looking at and we're going to talk about throughout this lesson. All right, so here, this is called the quadratic pattern. We call it the quadratic pattern because it's exactly, we're going to use the same strategies that we use to factor a quadratic, kind of like that, the reverse foiling or double distributing strategy here. So whenever you have a trinomial, okay, so if you're taking notes, please write this down. Okay, whenever you have a trinomial, three terms, okay, and the degree is even. So a quadratic 2, this is a fourth degree, a sixth degree, eighth degree. Okay, the quadratic pattern may work. The next thing you have to check, so you have a trinomial, it's an even degree. The next thing you want to check is the middle term. Okay, what is the degree on the middle term? If that is half the degree of the polynomial, so if this exponent, let me get my pen out. Okay, if this exponent right here, this 2, is half of this exponent, okay, then the quadratic pattern may work. So again, this first exponent, the degree of the whole polynomial, if that's even, and then in the middle term, if that degree, if that exponent is half the first, the quadratic pattern is a option. Okay, it doesn't automatically work, okay, but it may work. When we see that, that's what we want to think about. So here we have a fourth degree trinomial. So again, it's a trinomial, even degree, I'm thinking quadratic pattern. So what is quadratic pattern? Okay, so that is what we've always done with any quadratic, even though this is not a quadratic, it's going to factor just like one, which means that we're going to have a factor times another factor. So we're going to use our parentheses, right? And we're going to reverse FOIL. What goes in the first spot in each parenthesis has to multiply up to the first term in the trinomial. So what multiplies up to x to the fourth? And that's going to be x squared and x squared. Okay, so it's always going to be, right, half. That's why it has to be even. So if it was x to the 6 to begin with, we'd have x cubed, but here's x to the 4, so we do half of 4 is 2, so x squared and x squared. Now these last two numbers in each factor have to multiply up to the 48. And at the same time, they need to add up to the negative 14. So we know they both have to be negative. And so what times what is 48 and adds up to 14? That looks like 6 and 8. 6 times 8 is 48. 6 plus 8 is 14. So we have x squared minus 6, x squared minus 8. And then you would have to check to make sure that these aren't the difference of two squares, okay? And neither one is a perfect square here, so this is factored. All right, so this is called, again, the quadratic pattern. It works when you have a trinomial that has an even degree, and the middle term exponent is half that of the first. All right, and then if you could get the numbers to work out, okay, then we factor just like a quadratic. So from here, right, if we had to ask what the x-intercepts were, we would just set each of these equal to 0. So if, just changing the question here, right, if I set this equal to 0, I ask you to solve what makes this factor equal to 0. So you set each factor equal to 0, and you solve using the zero product property. X squared equals 6, square root both sides, and x equals plus or minus rad 6. So if I was graphing this function, I would have x-intercepts, okay, at positive rad 6 and negative rad 6, and also set this factor equal to 0, add 8, get x squared equals 8, square root both sides, so x equals plus or minus 2 rad 2. So I'd also have x-intercepts at positive 2 rad 2 and negative 2 rad 2. So I'd have 4 x-intercepts on this problem, which makes sense based on what we learned on graphing. The degree is 4. Okay, we could have up to 4 x-intercepts. All right, so again, that's factoring is what we're working on today. And then later this week, we're going to take it to this step where we're going to use factored form to find the x-intercepts. All right, so there we go. All right, the next strategy is called factor by grouping. When does factor by grouping a valid strategy? That's when you have your polynomial has an even amount of terms down here. All right, so this has 4 terms. That's pretty much what we're going to be focused on in this class, is only with the 4 terms. But factor by grouping may work with 6 terms, 8 terms, any even amount of terms, because you're going to break them up into groups. All right, so we need to have an even amount so we can break the groups evenly up. All right, so, but for this class, we're just going to be working really with polynomials with 4 terms. Doesn't always work with 4 terms, but we want to check because it's easier than the other strategies which we're going to learn next week, rational root theorem and so forth. So for factor by grouping to work, what you do is you're going to divide this into 2 even groups. So if there's 4 terms, you're going to divide it into 2 groups of 2. So you're going to look at the first 2 terms, okay, and then the last 2 terms. So you look at the first 2 terms and you say, what do those 2 have in common? So we're just taking out a GCF, a greatest common factor, of these first 2 terms. And so they both have an x squared in there. So I'm going to factor out an x squared. And so x squared times x is x cubed. And then x squared times negative 5 is negative 5x squared. All right, and then we look at, we move to the next group now. All right, and 2x and 10, so what do those have in common? A 2. So I'm going to take out a positive 2, so it's plus 2 here. And that leaves me with x minus 5. Now, how do I know that factor by grouping works? Is at this step, okay, these 2 are the same, factor by grouping works. So what this tells me is I could continue to factor now because these 2 terms have a common factor. They both have an x minus 5 in them. All right, so if I take out that x minus 5, that's one of my factors, right? I factor that out again. And what am I left with? Okay, so if I factored that out, it's almost like pretend like that's gone because I factored it out. It's now in front. What's left is x squared plus 2. All right, and then I have a quadratic right here. So again, I check to make sure is that a difference of squares? It's not, so I am done factoring right here. All right, so x cubed minus 5x squared plus 2x minus 10 factors down to x minus 5 times x squared plus 2. All right, so again, recapping the steps for factor by grouping. Okay, it must have an even amount of terms. So this one has 4 terms. And I divided it into 2 groups of 2. So the first 2 terms are grouped together. The last 2 terms are grouped together. Then I do GCF. Okay, GCF on the first 2 terms is an x squared. I factor that out. It leaves me with x minus 5. On the last 2 terms, the GCF is 2. Factor that out, and that leaves me with x minus 5. Since x minus 5 was in both of my groups here, I could factor that out again, and that leaves me with what was in front of the parentheses, x squared plus 2. All right, then you just double check. Okay, you're going to be left with a quadratic here. Make sure you can't factor that quadratic, and since you can't, okay, you're done. This is factored form. All right, so now if I go ahead and say this equals 0, okay, what would my x-intercepts be? So obviously this first one's very easy here. I get x equals 5. So that's one of my x-intercepts, one of my solutions to the 0. And then over here, though, if I set x squared plus 2 equal to 0, I'm going to get an imaginary answer, right? Because if I subtract 2, I get x squared equals negative 2. And then when I square root that, right, I get I rad plus or minus I rad 2. So what this tells me is that this graph, if I were graphing this function, I would only have one x-intercept at 5 because the two other zeros are imaginary. All right, complex roots right there. So we'd only have one x-intercept on this graph if we were to graph it. But we have 3 solutions, which we should because the degree is 3. All right, the next special polynomial that we get factors called the sum and difference of cubes. So here is the pattern. So if you have the sum of cubes, a cubed plus b cubed, okay, so we got x cubed plus 8 because 8 is 2 cubed, right? B would be 2, right? A 3 cubed is 27, so if it was x cubed plus 27, then b would be 3. And just factors following this pattern. A plus b, so you cube root both of those, whatever those terms are, right? Cube root both of those, and that's what you get. The sign here is going to stay the same. And then it's going to be a squared minus ab plus b squared. All right, and that's factored form. This quadratic right here will never be factorable. All right, so you're done. This is the form. And if it's a difference, right, just look at the signs change a little bit. It's a minus b, and then a squared plus ab plus b squared. All right, there's a little acronym that people use to help remember the signs of this, and that acronym is SOAP. Okay, and so what that stands for is same, opposite, and always positive. Okay, so what do I mean by that? Same, opposite, always positive. So in the first parenthesis, that sign is always the same as the problem. The next sign is always opposite. And then the last one is always positive. So the acronym SOAP will help us remember our signs when we get a plus or a minus, a sum or a difference of cubes. So let's take a look at one. All right, so I'm looking at this one, and this one doesn't look like it's the sum or difference of cubes because we're starting with x to the 4th, which is not a perfect cube. But as we do with all factoring problems, you should always look for a GCF first. And so in this problem, that's what I'm going to do. There's an x in both of these, so I'm just going to rewrite this as x times x cubed minus 27. Now, 27 is a perfect cube. It's 3 cubed. So if it helps, rewrite it again. Okay, this is an extra step. You don't need to do this, but sometimes it helps to write it out. It's x cubed minus 3 cubed. Okay, and what this helps is this helps me make a connection to our notes from the last slide. A cubed plus b cubed. A in this problem was x and b is 3, right? So a cubed, okay, minus b cubed. This is the difference of 2 cubes. Okay, so we're just going to follow the pattern. Wherever there's an a, I'm going to plug in an x. Wherever there's a b, I'm going to plug in a 3. And so my factored form, if I use the SOAP acronym, okay, same. So my first parenthesis, don't forget about the x, okay? But my first parenthesis will be a minus b, so x minus 3. Then it's a squared, so x squared. Now this next sign is opposite, so plus ab, so x times 3, so 3x. And then always positive, b squared, so 3 squared is 9. And so this is the complete factored form of this problem here. So if I were to, again, same as the last 2 problems, if I were to erase this and say, hey, set this equal to 0, okay, 2 of my answers are going to be easy to come by. All right, the factor for x, that's just x equals 0. For x minus 3, it's just x equals 3. All right, but for this quadratic, Okay, it's not factorable, so I'm going to use the quadratic formula. All right, if I do that, opposite of b, so negative 3 plus or minus the square root of b squared, so 3 squared is 9, minus 4ac, 4 times 1 times 9 is 36, all over 2a, so 2 times 1 is 2, right? So I get negative 3 plus or minus square root of negative 27 over 2. And so if I continue to simplify this down, negative 3 plus or minus, so 27 is 9 times 3, so that's 3 rad 3. So negative, I'm sorry, not negative, eraser, Control Z. All right, 3i rad 3 all over 2. And I'm just going to actually break this up so it's in the right form for a complex number. So negative 3 over 2 plus or minus 3i rad 3 over 2. So those would be my 4 answers, 0, 3, and then here are my last 2 complex answers right there. All right, so now we're going to take some time in this video for you guys to answer a couple questions. So right here, I want you guys to factor completely here. So we have f of x equals x to the 4th minus 4x squared minus 45. All right, so what of the 3 patterns that we just talked about would I use here? Would this be the quadratic pattern? Would this be the factor by grouping pattern? Or would this be the sum and difference of cubes pattern? All right, so answer that question. Again, it's a trinomial, even degree. This exponent is half of that, so I will be using the quadratic pattern. All right, so go ahead and factor this now. All right, so I'm going to get my 2 factors, knowing that in the first spot, it's got to be x squared and x squared because that multiplies up to x to the 4th. And then what multiplies up to negative 45 and adds up to 4? It's going to be negative 9 and positive 5. Okay, so since I'm asking you to factor this completely, I'm not done yet because x squared minus 9, right, is the difference of 2 squares. So I can keep going here. So x squared plus 5, and then the x squared minus 9 factors to x plus 3, x minus 3. And now I have factored it completely. All right, next question for you. I've got x cubed plus 3x squared minus 4x minus 12. So which of the 3 strategies are we going to use here? Quadratic pattern, factor by grouping, or sum and difference of cubes? So we have 4 terms. It's an even amount. So we will be using factor by grouping. Get rid of that. Oops. Let's get rid of that. Okay. And we're using factor by grouping here. So again, with factor by grouping, all right, you're going to group the first 2 terms. You're going to group the last 2 terms. All right, so this has a negative right here. So the GCF for this second group is going to be a negative. Let's go ahead and do the first. So what does x cubed and 3x squared have in common? And that's an x squared. So I'm going to take out an x squared. And that leaves me with x plus 3. And then the last 2 have a negative 4 in common. So I'm going to take out a negative 4. And that leaves me with x plus 3. So factor by grouping works because they both have an x plus 3 in there. So I'm going to take that out. When I take out the x plus 3, what am I left with? I'm left with x squared minus 4. All right, but that is a difference of 2 squares, so I need to keep going. So I get x plus 3, and then x plus 2, x minus 2. All right, now here we have x cubed minus 64. So which pattern is this? So we have a binomial, right? We have a perfect cube and a perfect cube. So is this factor by grouping? Is this quadratic pattern? Or is this the sum and difference of two cubes? And so this is the sum and difference of two cubes. And more specifically, this is the difference of cubes. All right, so if I need to solve this one, all right, I'm just going to follow my pattern. So on this one, okay, a is x. I'm just going to rewrite this. This is x cubed minus 4 cubed. Okay, so a is x and b is 4. All right, this is the difference, so it's going to start off the same. So x minus 4, a minus b, times a squared plus ab plus b squared. So we have x plus 4x, and then 4 squared is 16. And so this is now factored. All right, so you've now seen seen examples of each of the special types of factoring, and you have had a chance to practice one of each. All right, so you'll now do your homework, which will be more practice on all these. The worksheet will be in Canvas.